We've all heard about global warming and its effect on the climate around us, but what about someplace colder? A place that thrives on sub-zero temperatures. What about the Arctic? The Arctic is covered with a blanket of sea ice that is so large it is the size of a continent. There is always a layer of ice surrounding the Arctic, but every year the ice grows in the wintertime and shrinks in the summertime, as shown in this model produced by NASA. This frigid place is home to a variety of animals, from big polar bears to tiny phytoplankton. These animals have adapted to Arctic life, making it a very delicate ecosystem. However, their habitat is changing as the Arctic is warming.
Scientists monitor the changing landscape using satellites. NASA's Aqua satellite contains an instrument called the AMSRE. The AMSRE detects sea ice cover by reading waves of light. From these satellite readings, images can be produced that visualize the thickness, extent, and age of the ice. For example, these images show the age of sea ice, red as old, orange as mostly old, purple is mostly new, and white is new. As you can see here from these 2 December images, there is a drastic decrease in old ice from 2004 to 2009, which shows that sea ice is having a difficult time surviving hot summers.
This animation depicts the winter seasonal surface temperature trend over the Arctic from 1981 to 2009. The red represents the surface becoming warmer, while the blue represents the surface becoming cooler. Since 1950, the Arctic's average air temperature has increased by 3 to 5 degrees Fahrenheit. The winter air temperatures have increased by 7 degrees Fahrenheit. Satellite images show that increasing temperatures will cause the sea ice to shrink more and more every year.
A good question to ask is, how is the Arctic warming in the first place? A natural cause for this melting is a change in atmospheric patterns controlling wind and pressure systems, causing the sea ice to be blown out into warmer water. However, these changes alone are not significant enough to cause the sea ice to melt as much as it is.
The main reason is greenhouse gases, which trap solar radiation as heat, warming the Arctic and causing the ice to melt. Ice acts like a mirror, reflecting most of the trapped radiation back into space. On open water, the solar radiation is mostly absorbed, making the water warmer, which in the Arctic would cause the ice to melt. And as more ice melts, even more solar radiation is absorbed.
As the sea ice melts, polar bears will lose the ground they hunt on, causing a loss of their main food source. In turn, this will force the polar bears to relocate and readapt. However, the lack of sea ice will provide a perfect opportunity for floating plants and animals like phytoplankton and zooplankton, which use sunlight as well as nutrients from the water to grow. With a substantial increase in their growth, they could eventually eat up all of the ocean's nutrients, resulting in massive die-offs of phytoplankton. According to this food chain, phytoplankton are a source of food for zooplankton. So if the phytoplankton disappear, then the zooplankton will soon follow. This trend will continue up the food chain, eventually affecting seals and polar bears as well.
Greenland is a large country in the Arctic that is covered by frozen freshwater, whose shores are surrounded by sea ice. If the sea ice disappears, Greenland's coasts will be exposed, allowing the ocean to melt the freshwater ice covering Greenland. The introduction of large amounts of freshwater from melting ice will affect the ocean pattern, distributing warm waters throughout the oceans. This pattern is known as the thermohaline circulation. The thermohaline circulation causes warm water to flow from the equator to the North Atlantic Ocean due to differences in saltiness of the water. With an increase in freshwater input into the North Atlantic, these waters would become less salty and the circulation pattern could be stopped. Because this warm water flow warms the northern hemisphere, a shutdown in this pattern could cause the northern areas to become incredibly cold. The Intergovernmental Panel on Climate Change, abbreviated IPCC, has used computer models to visualize what will happen to the sea ice in the future. According to their predictions, by 2050, the Arctic is expected to have lost 40% of its sea ice permanently. But if we compare the melting rate of the sea ice seen from satellites to the predicted rate created by the IPCC computer models, we notice that the sea ice is melting faster than predicted. This would lead us to believe that the permanent loss by 2050 will be greater than 40%.
Although the Arctic seems far away, it is obvious that changes in its climate will directly affect the climate around you. Through our research, we have learned about some major problems in the Arctic and have come to the conclusion that global warming is having great effects on its frozen ecosystem. It is important to remember that if we do not monitor these changes closely, our ecosystem could be affected too.